Hello and welcome to Software Architecture course. Now we will learn design patterns, basically which models the interactions, which is basically the behavior. In this series, let us consider an important design pattern called command pattern. The reason for using command pattern is that it may be necessary to encapsulate a request in an object, and this would allow parameterization of clients with different requests. So basically each request can have different types of parameters meant for different clients. Not just that, I'm not talking about the input parameters, output parameters of the particular function, but what I'm talking about is basically a customization of the request, slight variation of the request that's used for different clients. It may also be necessary that requests are given to a server and the server is not able to process a request, but it can basically keep the request in a queue and then process them one by one. So these are the motivational scenarios. So let's look at the applicability. As I said, that it essentially parameterizes the objects depending on the action that they must perform. We will look at an example for command pattern to understand what is meant by parameterizing an object. Plus, as I said earlier, it needs to queue the commands and then execute them later. Need to provide undoable actions. Essentially, suppose a command is executed and then later on you need to unroll it. You need to basically roll it back. So you need to roll it back to the previous state. Examples are plenty. In many of these GUI based applications there are undo commands. So a command pattern would basically can be used to implement undo. Essentially what's going to happen is that the execute method, which is going to execute the main algorithm, will memorize the state so that it can revert the state back. So the important part is that in this scenario is that the command that's going to be executed, if it is wrapped as an object, then and when this object is passed, then not just the command but associated with the command, the environment, the context, the necessary prerequisites are also wrapped within the command object. So and that becomes something that can be transferred. So meaning that if there is a client and the server, the client can basically send a command as an object plus some environmental, some necessary contextual information. They're all wrapped together and the whole thing is sent to the server, and the server can basically execute it based on that environment or based on that context. Another scenario is that you need to build a system that comprises of many high-level operations, and each high-level operation requires many primitive operations. In that case, command pattern is also quite useful. Finally, it is necessary to decouple the invoker from the action performer, client and the server. So the invoker is a client and the server, and if you want to decouple it, then command pattern is a very good way to really perform the decoupling. So in this context, producer-consumer design pattern is also relevant, which is what is called observer. Actually, in a complex system, typically the producer-consumer design pattern and the command pattern often go hand in hand. So let's look at an example and understand this command pattern in more detail. So here there is a command which is basically the order executor. And there are different types of order executors. Like in this case, it's a trading example. Suppose you are building a trading platform, a stock trading platform. So buy a stock or selling a stock are essentially two operations which inherits from order executor, and it has got a method called execute. Obviously, in the base class, there is nothing there inside execute method, or maybe even if it is there, it might be some basic primitive operation. So we have this buy stock and sell stock. These are essentially the commands which are going to be executed. Now there is a trading agent. So this trading agent, in this case, trading agent actually sends these orders. So what's happening in this case is that there is a list of orders, and there is a particular method called place new order, and there is a method called execute order. And buy stock and sell stock, they're using another class called stock trader. Then I have got my own application. So let's look at their roles. So this is the invoker. The trading agent is the invoker. So this invoker, it basically asks the command to carry out the request. So this is the invoker which says that either buy or sell. Order executor is essentially the abstract command. This one actually executes an operation. Now buy stock and sell stock, these are essentially concrete commands inherited from the abstract command class, and it actually implements the execute method. So when it implements the execute method, what happens is it essentially calls inside the execute method, it essentially calls the stock trader class. So this is called a receiver. So we have got essentially four main parties here. One is the invoker, another is the abstract command, another is a concrete command, and the last one is the invoker. So it is a receiver who knows how to execute a particular operation. In this example, this is stock trader is, you can imagine that this is basically the trading house. So it's basically a stock exchange, for example. The stock exchange actually knows how to buy or how to sell a stock. So the core algorithm of actually buying or actually selling a stock is there with the stock trader. It is there with the stock exchange. But these commands are, and this invoker, these are outside the trading agent. Essentially, these are, you can imagine that they are kind of traders. It can simulate a trader. What trader does is, trader essentially calls the stock exchange to buy or sell, and so essentially this execute method in turn is going to call buy and sell. But this buy stock or sell stock, these are the command objects. Now this trading agent essentially creates a set of command objects. So here in the list, it maintains a list of command objects and it executes those command objects one by one. So you can imagine that this trading agent has, let us say, many such clients like my application. They all place orders and they are all put in a queue and they are all executed one by one, and those executions essentially happens here in this stock exchange. So let's look at the example here. So here we will see that this is the main class, which is essentially the usage, the client. Here what does the client do is, so client essentially creates a stock trader, new stock trader. Then it creates a command called buy stock, BSC, and creates a sell stock command, SSC, new sell stock. It has creates a trading agent, and then it says agent dot place new order by agent dot place new order sell. Then what agent does is the agent essentially executes these commands buy and sell, and they in turn typically goes to the receiver, who is going to finally execute it and then give it back. So this particular code that I have shown, this code is a code that's there in my app class. So this agent essentially places these commands in a queue and then executes it. Question is why? Now there might be a scenario that a request that's placed may not be executable immediately. Specifically, this is a case when you need to cater to massive number of requests, like in this case stock trading. There are many people placing so many orders throughout the day. So for that reason you need to definitely use a queue to prioritize and then execute. Moreover, there can be some other logic that the agent can apply, that you can basically place a command maybe in the evening, and the trader remembers it and then executes it on the next day. So, or suppose it is the request comes on Saturday or maybe Sunday, then this request is kept till Monday, and then on Monday it is executed. So the logic that it should be executed on Monday, and it should store the command till that time, this logic is there with agent. If you directly use the API of stock exchange and try to buy or sell, then it will give you immediate reject, that it is not possible. But with this kind of logic present in the agent, one can have more sophisticated way of handling those commands. Now these buy or sell commands, when it is executed, this buy and sell essentially interacts with the actual stock exchange. There might be multiple stock exchanges, and then depending on where it gets executed, it can basically get a result back. So this buy command essentially can wrap multiple receivers as well, but this whole thing is completely shielded from the user. User can even say that buy at the best price. So that logic will be there possibly with the buy command. So let's look at different implementation issues here. How intelligent command should be. On one hand, it could be really a simple link. It does nothing else. So the command is just a link. It just passes the request to the receiver, waits for the response, and just give it back. Or it could be very powerful, implements everything. It does not really need any receiver. It could be at any of these ends. It could be either this end or that end, or maybe somewhere in between. All depends on the scenario. The intelligence of undo and redo can be maintained using the command pattern. Essentially, a command can keep a snapshot of the receiver state just before calling the receiver. So just before calling the trading agent, it might just give a snapshot, and then it calls a receiver for any undo or redo operation. Suppose that the request fails, then in that case it can redo it. However, this requires memory because these snapshots needs to be stored in memory. It also stores a set of performed operation, so that one can apply inverse operations if there is an undo request. This undo typically is applied in the context of a GUI system. There could be asynchronous calls. Invoker essentially can send a request in separate threads. Now Invoker can actually use different kind of thread pools to manage this. Essentially, that queue that I talked about, which contains a list of commands, now from that queue, when these commands are dispatched, it might be dispatched to different threads in order to parallelize it, and there could be a thread pool using which the invoker can dispose those requests one after another. It can, but of course when there is a thread pool, then there is a limit of number of threads that can be executed, and then only to those many workers the invoker can actually ask to execute the command. So this command pattern and worker pattern typically are very useful in the context of designing a server. And once again, when you're designing a server and you're thinking of architecture, then you can think of basically the broker pattern. And what broker can do is broker can do such kind of request buffering, and then sending requests to different servers and so on. Even at the server level also such things can be implemented. Let's look at a few subtle points here. So it may look similar to strategy pattern because even in strategy pattern also it is wrapping an algorithm or a task. But unlike a strategy, it is not about multiple implementation of the same algorithm. Like buy, you don't have multiple versions of buy. It's basically buy and sell. Of course, you can have, let us say, a straight buy, basket buy, or and so on. Then, but they are not really multiple versions, but they are really different algorithms. In strategy, it is exactly the same algorithm. Like for example, sorting, but multiple ways of sorting. Command really encapsulates the state and the action together. This is what I was saying, that when a particular operation is performed, it is performed on a particular context or a state, and this particular command pattern essentially wraps both the state and the operation together, and that sometimes becomes quite useful. And command pattern in the command pattern basically makes a command request to an object, and which can be passed around, and very useful in the context of client and server communication. In fact, redo undo can also be maintained because the state is actually maintained here. In the context of an application, you typically use many commands, many command objects actually at any given point in time. So, however, in the strategy, you choose either or. So, if you are choosing, let's say, a robot movement, you choose either aggressive movement or a normal movement or a defensive movement. You don't choose all of them together. However, in the context of command, you choose buy, sell, all of them together, because it is not either or. So that's all for the design patterns. In fact, we covered structural creational as well as behavioral patterns, and then today we completed the behavioral patterns. There are many other design patterns. In fact, this design pattern community is quite active, and that's evolving. So those are definitely available. There are many such resources available in the internet in the form of advanced books that you can refer to. So the set of patterns that we covered in this course are really essential one and basic ones. Thank you.